Chapter 4, Section 5 is triangle congruency by using side, 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 and side angle side. Okay, so basically these two theorems that we're going to be using are how we prove or how we take information from the triangle and prove that two triangles are congruent. So triangle rigidity is if the sides lengths of a triangle are given, then the triangle can only have one shape. So if you have all the sides, you can only have one shape associated with that triangle. So let's look at these two triangles. Okay, if you notice AB, BC, and then CA here, I've listed their lengths. And I've also listed the lengths here for EF, FD, and DE. Now if you'll notice, EF and AB are congruent. They have the same measure. BC, same measure as FD, and DE, same measure as CA. So since they have the same side measurements, these two triangles are congruent. Triangle A, B, C is congruent to triangle, and don't forget to pair up the points here. So A is between this segment and this segment, so E. B between these two segments, so F. And then D between those, it pairs up with C, so that's D. Okay, so triangle ABC is congruent to triangle EFD by side, side, side congruency. All three of their sides pair up with another one. So this one pairs up with this one pairs up here, and this one pairs up here. All three sides don't have to be equal to each other, so it doesn't have to be 6, 6, 6, or 5, 5, 5, 5, 5, 5. All it has to do is this length pairs up with this one. This length pairs up with this one. This length pairs up with this one. So this postulate says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Okay, so that's the theorem here. So let's look at an example. We have two triangles here. We have triangle A, B, C. Okay, so we're going to see if it is congruent to triangle. We'll start off with A. So A, D pairs up with B, and then C pairs up with C. So these two triangles. So I know that AB is congruent to AD, and BC is congruent to DC. Now all I need is one extra side. Notice they share AC. So if they share AC, then that means that they are congruent to one another. AC for triangle ABC is the same thing as AC for triangle ADC. So since this triangle pairs up with the sides, pair up with everything here, we can say that this triangle is congruent by side, 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 side. Okay. All right. So if we had, for example, let's say that this was 4 and this was 3x minus 5. Since they're congruent, I can take 3x minus 5, set it equal to 4. That's a 5. And solve. So 3x equals 9, so x equals 3. Okay? All right. Okay, the next postulate that we're going to use includes a definition, an included angle. Okay, an included angle is an angle formed by two adjacent sides of a polygon. So in this case, two sides of a triangle. So I've given two sides here, AB and BC. So AB and BC include angle B here. Right here, this angle. Okay, this is the included angle. All right. because it's in between AB and BC. Okay, this segment and this side. It's in between those two, so therefore it is the included angle here. I also have that same angle here. Okay, angle EE is included in DE and EF. Now, the side angle side postulate says if two sides and the included angle, so the angle in between those two sides, are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So triangle A, B, C, and triangle D, E, F here are congruent because if you look, AB is 3.1, DE is 3.1, so they're congruent. BC is congruent to EF, both of them are 5.13. Now, since I have these two sides, I look at the angle in between them, only the angle in between them. 75.41, 75.41. So therefore, this angle is congruent to this one. So since I have a side angle side and a side angle side that are congruent, I can say triangle ABC is congruent to triangle DEF by SAS. Okay, example here. If I look at this triangle, okay, I see that AB is congruent to DC, and I see that angle ABD is congruent to angle BDC. So I have a side angle. I have a side angle, so I need another side. Well, if you look, BD is shared. Okay, BD is shared by the two triangles. So therefore, I have a side angle side, side angle side. So this one's congruent, this is congruent, and then BD is congruent to itself. Side angle side, so triangle ABD is congruent to triangle A pairs up with, let's see, A pairs up with C. B pairs up with D. And then that leaves B. Okay? All right, so this triangle is congruent to this triangle by side angle side. All right, that does it for Chapter 4, Section 5, Triangle Congruency, Side, 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 and Side Angle Side.